Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulillahi Kareem. This problem is related to integral transform. Uh, Calculate the Laplace transform of the function ft is equal to t square using the definition of the Laplace transform. We have to use a definition of Laplace transform. We know that Laplace of any function is equal to integration from 0 to infinity e to the power minus pt. Here e to the power minus pt is a kernel for Laplace function. This function is written here ft dt. This is definition of Laplace of function ft. We use this definition and find the value of ft. Here we are given ft in terms of small letter, so we use here small letter ft. Ft is given t square, so we put both side ft is equal to t square. 0 to infinity e to the power minus pt, and this value is t square. We know that the p is real, positive real number. We have to find this integral by using the formula integration by parts. Here there are two functions, first and second. On integration, multiplication of two integration, we know that write first function as it integration of second function minus differentiation of first function and integration of second function, and on multiplication of these two values integrate two function. Here we take variable x, but in our question it is given t. So Laplace of t square is equal to and we always consider first function, that function which becomes reduced power on differentiation, because we know that the differentiation of t square is 2 into t, and after differentiation it's become 2 into 1. So after 2 times differentiation it's become constant, so we choose this value. If we choose this function first, then differentiation of e to the power minus pt is also e to the power minus pt, and constant minus p divided by minus p. What this value will neither we terminate, so we consider t square is first function and e to the power minus pt is second function, and apply this formula. We get first function, write first function as it integration of second function with respect to t, and apply the limit here 0 to infinity minus integration, apply limit 0 to infinity here, which is limit here from here, and differentiate first function. We know that differentiation of t square is 2 into t, and integration of second function I write e to the power minus pt with respect to t, and on multiplication we integrate with respect to t from 0 to infinity. Now in next step, t square, we integrate this value. We know that integration of e to the power minus t is e to the power minus p, but here it is not t, so divide the coefficient of t, which is minus p, so I divide minus p here and apply this limit 0 to infinity minus 2. Here 2 is constant, so take out 2 from sign of integration, integration from 0 to infinity, write t here and integrate. This value is same as this value, so you can write this e to the power minus pt upon minus p. This is same value, so I write it, and minus p is constant, so we can take out minus p from this sign of integration, and this bracket is useless, and now I find this limit by using limit. What I not write here limit, what I tell you something. If you put upper limit here, e to the power minus put value of t is infinity here, we know that e to the power minus infinity is 0. So upper limit is 0. What it is not accurate, what you can do it without any distinguish, and what this value is we will get by using limit. What this process is long, so I skip this due to time consuming here. You can write, you can consider first put the value of e to the power t is infinity here, and you get e to the power minus infinity, it becomes 0. So write 0 here. What it is limiting case, because if you put here infinity, so this form becomes infinity into 0, which is indeterminate form, so you cannot write 0 here. But if you consider my trick, you can write 0 here. It is clear, it is not wrong, because on solving by using limit you will get 0. And also lower limit by putting t is equal to 0, so then t is equal to 0, put here, or here this lower, there is no problem in lower limit, but upper limit is you direct, if you direct put this value, you get indeterminate form. So this value if you want to accurately, so apply limit and solve, and then you find 0. But for this question you can write 0 by putting the here t is equal to 0 to t is equal to infinity here. Take minus p from this sign of integration, then this sign becomes positive 2 upon p. Now this integration become very simple, t into e to the power minus pt. It is relevant to our starting this, but power of t is reduced by 1. So after integration it will free from t, and then we get the required value. So again apply this formula by considering this t is a first function and e to the power minus pt is second function, and this is value 0 becomes 0, so we get 2 upon p, and apply formula first function as it, integration of second, you can put direct value, what I write e to the power minus pt dt, what I apply the limit 0 to infinity here, and minus for second function 0 to infinity, differentiate first function, differentiation of t with respect to t is 1, and integration of second function I write e to the power minus pt dt. You can write direct its value, but I write in detail, and multiplication of this with respect to t, integrate this value. This bracket is closed here because 2 upon p is multiplied to whole this integral. So I apply this square bracket 2 upon p. T into this integration we for we encounter previously, and so write this value again. Put this value integration of e to the power minus pt is e to the power minus pt, and coefficient of t is minus p, so divide by minus p, and after integration we apply the limit. Lower limit is 0 and upper limit is infinity. Minus integration 0 to infinity, here 0 to infinity, 1 is multiplied to this, and this integration is equal to e to the power minus pt, same as this value, upon minus p, integrate with respect to t. This value is equal to this, and multiply by 1 we get this value, and it's close this bracket because 2 upon p multiply whole this value, and same argument apply upper limit minus lower limit. Put t is equal to infinity here, e to the power minus infinity is 0, so upper limit 0 and lower limit 0. But I also said that you can use this value. What actually finding process is long, so I not show this here in this simple question, which is equal to left hand side is you can write as previously, right hand side is 2 upon p, and upper limit is 0 minus lower limit also 0, because on putting value of t is equal to 0, this becomes 0. And take 1 upon p from this sign of integration, then this sign convert to plus by this sign, so this becomes 1 upon p, 1 upon p, and integration 0 to infinity e to the power minus pt dt. 2 upon p, this value becomes 0, here only 1 upon p, and also we have to integrate this value, which is e to the power minus pt, and coefficient of p is t is minus p, so I divide it by minus p, and apply the limit. Upper limit is infinity, lower limit is 0. On solving this we get find the required answer. 2 upon p, and you can open this bracket and multiply 2 upon p to here, we get 2 upon p into p square. Only we have to put the value of upper limit and minus limit. So here is no problem, you can show here by putting t is equal to infinity, infinity into p is infinity, and on minus p is on denominator, in denominator, so I write minus p here. This is upper limit minus lower limit. For lower limit put the value of t, which is 0, then this value e to the power becomes equal to 0 upon minus p. We know that e to the power minus infinity is 0, and e to the power 0 is equal to 1, e to the power 0 is equal to 1, so 2 upon p square is equal to e to the power minus infinity is 0 upon because e is greater than 1, every value is greater than 1 on e to the power minus infinity 0 if a greater than 1. So e to the power minus infinity is 0 upon minus p minus 1 upon minus p. This 0 upon p is 0, so 2 upon p square. We know that p is positive, so this value is 0, minus minus becomes plus 1 upon p. Then you can write 2 upon 2 into 1 2, and p into p q. This value of Laplace of t square, which is equal to 2 upon pq. You can also write it as 2 into 1, and Laplace of t square you can write factorial 2 upon pq. Also we know that the gamma 3 is equal to factorial 2, because gamma n equal to n minus because gamma n is equal to factorial n minus 1. So apply this formula for positive integer. Here you can write gamma 3 upon p cube, which is Laplace of t square. You can use this formula or this formula. I prove this, and you have to learn by heart this formula or this formula and use in your question. Thank you very much indeed for listening me. Wa akhru dawana alhamdulillahi rabbil alamin.